So we're gonna write equations today from a word problem. Today you're only being expected to write the equation, not solve it. That's what you will do tomorrow. So tomorrow there won't be a video because you literally are just writing the equation from the word problem and then you're just solving it like we have been. So to be able to write an equation from a word problem, I first want you to be aware of this. You have done this in 7th grade. You did this in 7th grade a lot last spring. So don't think that this is something completely new. It really isn't. You just now have a variable on both sides. So we have this problem talking about a wireless company offering 2 cell phone plans. Plan A charges $24.95 plus 10 cents per minute. So I'm just going to highlight that because I know then that this is plan A. It charges $24.95, then 10 cents per minute for calls. Then plan B charges $19.95 plus 20 cents per minute. So I have 2 plans that are offering a different thing. And I want to know when the plans will cost the same. So the first step always is for you to determine what the variable is, what the unknown is in the problem. So when I'm looking at this, I know that it is originally $24.95 and then it's 10 cents per minute. I don't know how many minutes I am going to be on the phone. So that is my unknown, and each of these is how many minutes I'm going to be on the phone. So your variable is going to be minute, and we can define that using the letter M. Now, if you want to, you can use an X if you would like, but the M just kind of helps you remember what you're really looking for, right? So the number of minutes. Step 2 says to identify the coefficients. So is the variable being multiplied or divided by a specific value? And this number works with the variable, so think about the coefficient as the coworker. So whenever I am looking for my coefficients, it is what is affected by my variable. So I'm looking for my coefficient. So if you see it, it says 10 cents per minute or 20 cents per minute. So for plan A, my variable would be that 10 cents per minute. For plan B, it would be that 20 cents per minute. And so per means to multiply. So if I'm doing 10 cents per minute, it's like 10 cents per minute. So this is kind of like saying 10 cents per minute. That's the same way. Then the next step is to identify your constant. So your constants are the things that are constantly alone. It's like your starting value. So you know that your starting value for plan A is at $24.95. You know that's where it's starting. For plan B, it's $19.95. So for plan A, it's that $24.95. For plan B, it is, go back up, $19.95. I just want to make sure I'm using the right number. Now we want to piece it all together. So I know that for plan A, it is that 10 cents per minute plus the $24.95. So it's that 0.10 M plus that $24.95. So this is my starting value, and then I have to add that 10 cents per minute. For plan B, I know that it is 20 cents per minute plus that $19.95 that I have to start out with. And it wants to know when they cost the same. So same would mean that I want to know when they are equal to each other. So you're really looking at when they are equal to each other. So let's just look at one of the examples really quick, and then I will stop the video. I'm going to link another example at the bottom that's kind of like one that's a little bit tougher. So I know that Hudson and Knox are in a race. Hudson is running at a speed of 8.8 feet per second. So that is important, is that Hudson is running at 8.8 feet per second. Knox got a 30-foot head start and is running at a speed of 6.3 feet per second. So I know Knox is at 6.3 feet per second, and he got a 30-foot head start. So when I'm identifying my variable, what my unknown is it wants to know how many seconds will it take until Hudson and Knox have run the same number of feet. I don't know how long they've been running, so my unknown is seconds. And you can identify that with an S if you would like, My S looks like 5s though, so I'm just going to use an X in this case because I don't want that S to get confused. So when I'm looking at Hudson's expression, I know that he runs at 8.8 feet per second. So I know that Hudson is 8.8 feet per second. He has no starting value. He started at 0 at where he was at. However, Knox got a 30-foot head start, and he is running at a speed of 6.3 feet per second, plus he got that 30-foot head start. And I want to know when they will run the same number of feet, so I'm going to make those equal to each other. 8.8x is equal to 6.3x plus 30. I'm going to actually just go ahead and show you this next one down here. So number 6, it says 35 more than 0.8 times a number is, so we're looking at number 6. 35 more than 8.8 times a number is the same as. So I know that I have this on one side, and that is the same as is my equal sign. That's my equal sign. Is the same as 43 less than the product of -7 and the number. So I know I have 35 more than 0.8 times some number. I don't know what that number is, so that is my variable. Is the same as 43 less than the product of -7. So product, you need to know that product means multiplication. So the product of -7 and the number, so my unknown, and that is 43 less than that. So I've got to take away the 43. So your equation would be 35 plus 0.8x is equal to a -7x minus 43. Okay, try those out. There's only 5 of them for you to do. Again, you are not solving, you are just writing the equation. All